We've got browsing stuff here. Okay, ready to look at documentation. Now let's get into our project. Ooh, development 65k. Can we code this? And here we are. I am still waiting for the notification here on YouTube so that I'm finally I am still live, which I am now. Anyway, welcome everyone. Welcome to another stream. I do apologize for not being too active on streams in the past week or so. I kind of had a busy week last week, and yeah, apologies for that. Hello, Get2. How's it going, dude? It's good to see you here again, and it's been very nice to see you on the Discord as well. Anyway, how are you guys doing? I hope you all had a very good weekend, and I hope you all managed to kind of learn a lot or complete your, I guess, university assignments, right? Or whatever you guys were up to. And I also hope that you had some time for yourself away from the computer, because that's also very important. Don't forget to take time for yourself. So today's stream, what are we doing in today's stream? I have this project, which is a 6502 emulator that we did it on the stream quite a while ago now. I think the last time I did anything on this project was about 2 months ago. You can find it in this link here, which should be in the description as well, right? So I should have provided this for you guys. But yeah, I mean, it's basically just a very naive 6502 assembly emulator, right? So you give in the binary or the compiled 6502 and it will execute it, right? That's what it does. Last stream I was late because it did not notify me, but it did, but not this time. Well, thank you very much, dude. I would appreciate a like on the video as well if you can already do that. That helps me out massively. And yeah, I mean, I enjoy having you guys here from the start. To be honest, it's always good having someone here from the start, because sometimes I start the stream and there's like 0 people watching. I'm kind of just talking to myself, even though I know that like 100 plus people will be watching this video in the future. But it's good to talk to people live, isn't it? We are not drinking Coca-Cola today. We're drinking water because we're trying to be healthy this week. But anyway, so we have this 6502 emulator, and the whole application is just a CMake project, a good old CMake project. The only difference is that here we are using C++ 20 modules. So we set the standard to 23, and we set some of the settings that we need for the modules to work, essentially. And if you look at one of the libraries here, module library, so emulator, if you look at the CMake list for that, you can see that the CMake looks a little bit different, right? So what is this file set, CXX module stuff? This is all to make sure that the C++ modules will kind of work as intended, right? Hello, Random Nerd. How's it going, sir? It's good to see you here again. I'm really enjoying having like some of you guys coming back all the time. Truth be told, I did not have this months ago. So every time I did a new stream, no one would rejoin. But it's good to see that some people like watching me code. And yeah, as I said, it's a pleasure to be here with you guys. Anyway, so this is what a C++ kind of module file kind of looks like. So we have, it's mostly the same stuff. You have to put the keyword module at the start of the file, and in between the keyword module and this export module here, you have to put all of your old includes, right? So all of your preprocessor stuff is going to have to go here. It's just the way it works. And after that, you put export module and then the name of your module. And then you can just work with C++ modules. You've got C++ modules enabled from this point onward. So you can see here that there are some funny keywords like export module emulator, export namespace emulator, which exports this namespace emulator from this module. And anything inside that exported namespace is also going to be exported by transient. Is that the word? Transient. And that's whatever the advert version of that, or the advert, yeah. I don't even know the words I'm trying to say here. But anyway, it would transitively export everything. That's what I was trying to say inside the module. I like hearing you thinking out loud and commentate your decisions. Yeah, I mean, they're not very good decisions most of the time, But yeah, it's good to see how people think, isn't it? And the reason why I do streams, this is something I used to explain at the very start of this journey. I haven't really become that famous or anything like that, but I definitely gained a lot of following because of the streams, I'll say. So we used to have like less than 500 streams before I started streaming, for example, less than 500 viewers before I started streaming. And I started streaming to basically show people that, everyone kind of struggles with coding, right? Even someone like myself who has been in the industry for a long time, I still have to think very hard about some stuff. I still take time and I still make things wrong. Not everyone is amazing at coding. And especially, if you're used to watching people have like pre-edited videos on YouTube where they talk about their project and how easy it was for them to create something, that is not the whole truth. I just want you to know that. So it's good to see other people struggle here as well. I'm doing fine, sir. I was preparing for my interview that is scheduled to be tomorrow. That's amazing, man. So hopefully, fingers crossed, it will go well for you. Let us know what the interview is about, or what the job is about. I'd love to hear what you guys are interviewing for. Oh, what kind of interview? Yeah. So coming back here, we've got this whole sort of like emulator that essentially has a CPU structure, which has the registers, all the ones that we need. And we can take a look at that in a second. The registers are just like kind of bytes, really, except the PC is a 16-bit integer, which is what you get for 6502 machines. The pointers are all kind of 16 bits, so you have to have a 16-bit integer for that. We have the flags as well, which are kind of like just I guess there are, you could have done this with bit sets or whatever they're called in here. And we have the memory of the machine itself, which is just, roughly 65k of bytes. And the clock speed, that's what's defined by a CPU. And we also have all the instructions implemented somewhere. So if you take a look at this big, get instructions function here, this essentially returns a map with, the keys as opcodes and the values as instructions, right? Which this is, cheated a little bit. This is probably a little bit of, this is kind of the problem that we have when, kind of executing instructions. So like the way you execute instructions in an emulator, let me just get it for you here. So do we have Excalibur? This is a lesson for you guys. Why is it not in dark mode? This is way too bad. There you go. So, you may have some instructions like, or a program like, whatever, FF 0x A9. In fact, 0x A9, 0x, I don't know, 11, 0x, and let me just put these capitals so it's easier to identify what we're doing. So 0x, whatever, you get the gist, right? So this is a program here. Now, the way that we kind of execute code in a program like this, so this is essentially what an emulator does. You give in the program code to your emulator, and the emulator's job is to essentially pick out the important parts in order of this. So for example, this is an instruction. A9 is actually I think it's TXA or something. Let's have a look here. A9. Maybe we'll find 9A. There you go. I got it the wrong way around. So this opcode is instruction, and it's called transfer X to A. Right. So what this does is actually this will transfer whatever content you have in the X register of your machine to the A register of your machine. So this is what the CPU kind of looks like. You have like all your registers here, which will be something like A. I don't actually know what they're called, but we did go through them. So we've got all these registers, AX, Y. And these are things that basically store information on the go so you can do calculations with them. So X, Y. We have PC and stack pointer as well. These are special ones. And you also have some sort of like flags in here. And the flags are kind of, they do a different thing. So whenever you do a calculation, you may have the, so for example, the non-zero flag enabled. So these are all the flags. So you've got like N for, I can't remember what it stands for exactly, but 0 for zero flag, and so on and so forth, right? And all the emulator does is like it reads the binary of your program, and it will basically work with transferring data or doing calculations and moving data around in the CPU. So this is all that the emulation all that the emulator does. So essentially, you give in the input, and you will kind of like sequentially parse, the inputs, and maybe this is an instruction that takes a parameter, so you'll actually kind of read this window here, and so on and so forth. Like I said, you also have the PC where you can kind of edit that and do things like jumps, so you can kind of go back and forth between parts of the program. It gets more complicated, obviously, but this is essentially how a emulator works. That's what we're working with here. And we do have, or there used to be a very kind of nice page by a guy called Masswork, I think it was. So Masswork 6502, which had all of the instruction sets, right? So is my internet lagging by any chance? So all we got to do is like implement every single one of these instructions. That's what we do. That's what an emulator does. Anyway, going back to the chat here. Did I miss anything important? That's a nice t-shirt, sir. Thank you very much. Yeah, shirt of tea. That's a t-shirt. Web application developer cleared round 1 yesterday. Nice, dude. Online assessment test round 2. Supposed to be DSA. I went blind for a second there. Yeah. Sorry about the white pages. I do prefer dark mode. In the first round, they asked simple maths questions. For instance, given 2 trains speed, how long would it take them to cross each other? That's cool. There were only 3 normal registers. Damn. Yeah. For 6502, yeah. I mean, there are only normal 3, byte long registers, but that doesn't mean you only have 3 bytes to work with. You can put things in memory as well. That's essentially what your RAM does. So it's essentially how that happens. That sound a bit weird for a web application developer. Stream seems fine. Thank you very much for confirming. Anyway, so yeah. So currently, what do we have? We have actually a program that kind of just draws pixels on the screen. So essentially, like, we have a huge byte, a huge bit of memory. Do I have like something to describe that? No, I don't. Ooh. What if I go in here? Yeah, so we have basically like a massive array of bytes, and the size of the array is actually roughly 65K. And at some point there is I think it's a 30 by 30 region of that array where I dedicate to the graphics. So this program that I've got running here, which is like a test program, I can see what it kind of looks like. I think it is, so if we do hex dump test program, is that, yeah, pixel drawing, I think it should have been, not even this one. This is the program we're running. And this very small program just like goes into that range that I've got of the arrays inside and sets like integers inside there, which represents the colors or the color palette, and it just draws on the screen. That's all it does. We do have like more interesting code as well. So for example, there was something that one of our viewers made when I was streaming this. I think Robin's code v3, that's the one. Let's try that one, which actually draws myself on the screen in 6502. Let's see if that still runs, because I haven't actually tested this in a long time, to be honest with you guys. So if we do that, and then if we run this, does it still work? There you go. So it still works. So this is this is myself, apparently, and this is something that Robin did a while ago. Hello, Robin, if you're watching this, I'm not sure. I've not actually seen Robin in a long time. But, so far we have the ability to draw stuff on the screen, and we don't really support that many more things with this emulator, to be honest with you guys. But you may have noticed, right? You may have noticed that this is actually quite slow. In fact, if I change this to debug, and if I do a select configure preset, and I change it to Unix Clang debug, we're going to rebuild this. Let's just do a clean rebuild. And you'll see how slow this actually takes to do one draw iteration on the screen, which isn't ideal, right? So the goal for today is to kind of figure out what is actually causing this kind of slowness and see if we can improve it in any way. So I've got a few ideas already. So one of them I'll go through that. So, okay, so we, it took a little bit slower this time, a little bit, longer to draw. And I do have some what do you call it? Some profilers running here. So you can see that the function emulator took 0.7 seconds, right? Which isn't great, which is not great at all. So one iteration of drawing on the screen, you should be able to do these things like 30 times a second. And this is not anywhere close to that. So yeah, this runs in WSL with QEMU. No, this actually just runs in WSL with with just WSL. There's no emulation going on. I have the emulator compiled for WSL, and Windows just runs that. That's how it does. And it's even simpler than what you're thinking, dude. We don't need QEMU at all. But let me explain one of the things that I think is causing the slowness, right? So first of all, you guys are going to have to work with me on this because there is no IntelliSense here. I'm using C++ modules in VS Code. And every time I come across modules with VS Code, things don't work still. So I think, they still have a long way to come in order to support modules in C++ here on the VS Code stuff. Another thing that I've noticed as well is that I am not using ClangD. So I'm going to change this to ClangD. I'm going to install ClangD. Oh, I already have ClangD here, which is interesting. If I reload the window, what do we have? So I would expect ClangD to actually work a little bit better with modules compared to the C++, to the default C++ extension here with VS Code, which is, I think it's called CPP debug or something. So let's just move that to Clang again. ClangD. Let's enable it. Okay, so ClangD, download language server. Let's do that. Use the installed version. Okay, let's reload the window. So now the LSP should be working a little bit better, right? I saw the window and knew it was WSL immediately. OpenGL does not seem to work for me on the WSL on my laptop. It was an older Quadro card, but maybe that's why. I updated all my drivers, but it just refuses to work. It sounds to me like you're probably missing a library installed in your, like a Mesa library or something like that. Because Raygun, which is Raygun, sorry, Raygun is the, sorry, that is completely unrelated to this. Raygun is the Australian breakdancer. Raylib, that's what I meant to say, is the library we're using here for the graphics, and that uses OpenGL in the, under the hood. And I also had a hard time getting it to work with WSL, but eventually I did. There was just some missing stuff. So what I recommend is like reading the errors that you get when you try to initialize an OpenGL application, and just Googling the hell out of it, because you will find useful information, especially if you're on Ubuntu, which you probably are, right? If you're using WSL, it should work fine. But yeah, I mean, this is even worse now. So module emulator is not found. That is cool. Anyway, while we're at it as well, let's get code LLDB, because that also has, oh, we already have that. That has a better kind of debugging stuff than a debugging experience than the CPP debug. Anyway, so Clang, we've just established that Clang also doesn't work here. There is one thing that I forgot to do, is go into settings.json and go to the very end, and we have CPP debug. The IntelliSense scan, IntelliSense engine, disabled. That's the one. Let's reload the window. Yeah, because if you don't disable the IntelliSense that you get installed by default with VS Code's C++ extension, then ClangD doesn't work fine. But it still doesn't work anyway. So it was just my last try to get this working. But yeah, point is, you guys are gonna just have to work with me. Or be, bear in mind that the profiler stuff, sorry, the IntelliSense won't work very well. I have a desktop PC with GTX 1060 and it works on that fine. And I also have a laptop with AMD integrated graphics, and it works on that as well. It just doesn't seem to work on my laptop. Maybe, yeah, maybe you're right. Maybe it is the actual card. Right, first bit of performance improvement. We have this function called get instructions here. And if you look at what this does, it returns a C++ map, right? We're actually going to have to kind of find this like a caveman. It returns a C++ unordered map where the keys are the opcode of the instruction and the value is actually the instruction itself. But if you think about 6502, all of the keys are all of the opcodes are 2-byte integers, right? So they are just 2-byte integers. So, or a byte integer, in fact, not even 2 bytes. So instead of having a map here, which essentially means every time that you execute an instruction in C++, which essentially means you're having to find the value, we can just turn this whole thing into an array, right? So we can just do this map into an array. And this is something that is possibly, probably known as a precompiled table, for example, and is, and whenever you have a map in C++, you should be asking yourself if you could turn that into a vector, into an array instead, because sometimes you can. So yeah, especially when you're having like decoding and encoding tables, those settings tend to be quite good for having this sort of like optimization, right? So in here, what I'm suggesting is that we're going to be returning a stud array of std uint8, so not even that, a instruction, and we're going to have, however many instructions we're meant to have, which is 255, I think, 255 instructions, or 256, and that's the maximum number you can get with a byte, right? And this is what this thing should actually return, right? This is what we're going to do here. So let's try that, shall we? Now the problem is, obviously, we're going to have 250 different lines here. So I'm thinking of a nice kind of easy way to turn all of these instructions into like a line in the ordered line, I guess. So yeah, we can begin by ordering all of that, right? Refuses to work. Right, since both maps and arrays have retrieval times of 1, but the constant element is bigger since the maps need... Yeah, exactly. So even if you're using an unordered map, that is still going to be, a lot more expensive in terms of optimizations, in terms of efficiency, than looking up an array. What do you call it? A random access array, which is what the stud array will give you. So yeah, I mean, we're gonna have to like basically just kind of like sort this out first and then implement the paddings. Okay, so yeah, the sorting doesn't quite work the way I expected it. Yeah, I sort in ASCII mode. That's fine though. So maybe, right? Let me think about this. So let's remove all the comments here. Let's turn these things into a uniform thing, because I'm gonna run some like Vim magic here to turn all of these things into the array. So do we have any more of that? Okay. All right. So instead of returning that, I'm going to remove that return. And I'm going to remove this, remove that. And in here, what I actually want to do is to return the instruction array there. And I'm not sure if you may have already done this in the... Can you do a const expr where you flatten the map into the array? Yeah, I mean, the idea is to turn this into a const expr array. You're right. For now, I'm just going to return that thing here. So basically what I'm going to do is I'm going to create that array. Instruction, 256. I called instruction array or something, right? Yeah, instruction array, which will just have zeros everywhere and whatever the default initialization for the instruction is. I don't actually know. What is it? Now, this is the thing. Is it going to work or not? Because we have the instruction, which is instruction. So this is a function that does nothing, right? Okay. Yeah, I do wonder if this has a default initialization, because if it does, then this thing that I'm doing will work, because I'm essentially going to create that array and default initialize everything to it. Oh, why did it go away? And now what we can do is like a crazy macro here. So let's start recording. What we want to do is we want to do instruction array. It's going to be that. And then here we're going to do this. And I think that's it, really. So let's stop recording, and now we can do this on all of the lines, right? So let's just do a test real quick. Yeah, okay. So we can do that. How many lines do we have here, though? Okay, we have 50, 49 selected. I was just looking for, like, where does it tell me where the number of lines selected is? But it's here. We found it. That's fine. So what we can do is we do 49 L, and then this is gonna turn all of them. Well, this Vim emulation is so slow. It's crazy. Gonna turn all of them into that. Now, okay, this is basically what I wanted to do. Ooh, basically what I wanted to do. Let's go here. Wow, how'd you do that? It's like magic. Vim, dude, learn it. Vim macros. It's really useful. So now we have the supported instructions. Okay, maybe we can rename this. It doesn't let me rename either, does it? Oh, I hate not having IntelliSense working. Is there really no way to get modules working with LangD now? VS Code, C++ modules. This is really bad. Let's add support for modules. This is still last year. I remember seeing this thread. How to include C++ modules. IntelliSense is what I actually want. Configure C++ IntelliSense. Is modules mentioned here at all? No, it's not. So the default extension doesn't work. Can discern C++20 features. So the easiest way to do this is by adding the default standard to your JSON file. Not that this settings by default. Okay, no. I don't think this will help. Is there anything that we can do in here? Maybe ClangD? ClangD? Yeah. Standard? Default standard? Nope. Style. What do we actually have in here? So arguments, path, restart, trace, enable. Yeah, I don't think this is going to help at all. Now, yeah, I think I'm going to assume that it's still, modules are still not working instead of trying to spend a huge amount of time. Anyway, that's sad. I just wanted to get the IntelliSense working here. But that's fine, because what we can do is, again, for you guys that are very interested in Vim and how magic it is, you can just do something like, right? Something like this. Oh, nope, that's not what I meant to do. So if I select all of this again, we have that. And I want to kind of do replace instruction array. What are we going to call it? Supported instructions, I guess. Yeah, that one didn't quite match it, so this is supported instructions here. And yeah, we can just rename something in our code block, right? But unfortunately, I didn't select this one. That's fine. We can select that one, and then do this. Okay. Suggestion: get software which shows your keystrokes. Yeah, that's true. Should I try that now? I don't know. I'll try next stream for sure. I have seen streamers doing that, and I think it's useful. So yeah, at least you guys can see what I'm typing next time, right? So yeah, okay, all of them match now, even though I don't have IntelliSense. Now the problem is when we have get instructions, we were assuming that instructions kind of was basically a, what do you call it, a map, right? But let's go to execute next, where that is actually used, which has a program, and then in here we are going to swap this to an array of instruction, which are size 256 as usual. And whenever I was using instructions before, instead of finding, we can just put the command in there. Okay, so that will give us something. That will certainly do something. Now, it would be nice to also see if this is going to compile in the first place. So if found is not the end, so this doesn't really exist anymore. This is kind of just, you know, instruction. What did I have before? This is going to be instruction. Instruction, CPU, program. Okay, yeah, this is what we're going to have here, and then we can remove the rest of it, just like that. So, I mean, the question is, if we format this document, no, we don't have to do Clang format now. But the question is, if we have a command that we don't yet support, right? Because there are plenty of opcodes that I don't support yet. There's so many of them. I haven't really implemented all of them. And in fact, let's see if we can still get mass work. 6502. Let's just keep this page up. I actually think I've supported 49 odd instructions or something, right? Let's just take a look at this. So 52 instructions, right? I have supported 52 instructions, but how many of them actually are there? I want the instructions here. So 59 opcodes. There are 0 to 1. Well, do I know how many there are? Does it say anywhere? But I'm gonna guess it's more than, a lot more than 52, right? So if you just look at here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. So there's 16 here, 16 there. There's about 32 here. I'm just doing like a rough check. So there's, 52 just in these two like halves here. So I support basically half of the opcodes that are available. But I'm basically assuming that whatever instruction we kind of get from the execute next, right? So execute next. Yeah, so I'm basically assuming that whatever instruction I get here will be valid, but that's not the case. I want to return an error somehow. Yeah, that was so smooth. Suggestion get software. Okay, is that array just a function pointer array? Yeah, basically just a function pointer array. If you look at the instruction, it's using instruction somewhere. This is the value that we actually store there, and it's just a function object, which kind of is a wrapper on function pointers, if you think about it. But also works with lambdas, so you can wrap lambdas on these things. That's why I use those instead of just function pointers. So I would like to know a way here of kind of seeing whether or not we support a command. Or even better, it would be nice to kind of do a default initialization of function that will kind of throw an error, if it makes sense. So if you try and execute something that you don't yet support, that function will throw an error. I think there is some nice stuff here with with default initialized lambdas in C++23, which we are actually using, so we can make use of that. But let's just take a look at that. So essentially, I want to start every single opcode as an invalid function that will just like kind of raise an error, so throw an error or something. And you know, for the ones that we actually support, we're just going to override. So that's the idea here. So yeah, in this case here, we want to make sure that all default elements of supported instructions are pointers or functions that will raise an error, right? Somehow. That's what we want to do. Which is cool. So default initialized lambdas, C++23. There was something that kind of allows lambdas to be default initialized now. So I guess what I want to do is like default initialize array C++, right? That's what I want to do. To one default value in C++. Yeah, fill n, I guess. That could work. Do we have algorithm already? That might work. Let's try that. Do we have algorithm? No, we don't. So we need to include algorithm. And we've done that, and now we just have to fill n array. What does fill n actually do? I've used this function very few times before. Stud fill n. So it takes forward iterator and output. Yeah, my Giga chat stays hydrated. Hello, Arkonath. Hello, dude. How is it going, Ahmed? It's good to see you, man. It's been a while, hasn't it? It's been a while. To be fair, it's been a while that I've been coding as well. I mean, it's not on stream anyway. It's been over a week or so. I had a very long and busy week last week. I was out of home. I was in London, so it was very difficult to keep up with the with the work here. But we're going to continue it nonetheless. So we take the first iterator, the size, and the value. Okay. Yeah, current project hangs heavy, so nights are busy. Yeah, man, that's good. That's good that you are actually busy. And yeah, there is that for me as well. So we are trying to kind of get this thing that I'm working on done. But it's very difficult. It's a difficult project. And it gets more difficult every time I look at it. So it's just hanging as well, but I'm trying my best. Which means that, yeah, I've been doing some extra time, every now and then on the weekends. Yeah, so this person says that he works with array here, but I don't see that specialization in the array class. I just see a forward iterator and the size, right? So yeah, I mean, we're gonna just do that. So fill n begin of supported instructions, and then we're gonna do the size, which is supported size, and then now this is the interesting thing, right? So I have to match this to my instruction using instruction, which is a function that returns an optional of size t. Returns an optional of size t, takes a CPU and a spam of uint8, right? So I'm just going to copy and paste this because I'm definitely going to forget this. So this is what we want to do. We want to take in a emulator, or just a CPU here, because we are already in the emulator thing. It doesn't matter what we're taking, to be honest, and a spam here of const std uint8. And it doesn't also matter what we do here. We're going to return a stud optional of std size t. But then this is the important thing. We're just going to throw an error. We're going to throw a big exception here, and I'm probably going to have to include exception so I can have my own exception. And if I'm not mistaken, you have to do a exception what, right? So we have exception, and I think you can do the what function, which is a virtual. Yeah, okay. And that should return what? What does it return? Is it just a string? This is a const car star. All right. So, okay, that's fine. An easy fix should be making get instructions a const expr. Wouldn't that speed up everything greatly? Maybe. I may be wrong, though. Yeah, I mean, getting... It wouldn't speed up things massively here because we only call this function once, basically, when we run a program. What would be interesting is that if you const expr, then this function is gonna, inline the values, which is also cool. So we can do that. But because this function is only called once at the start of when you execute a program, the calling itself isn't the bottleneck. The bottleneck was looking up all of the opcodes. That was the bottleneck. Well, and it may improve things, it may not. We will see. I'm just doing this optimization anyway. If you only have one thread, then you don't need to pass the CPU into the function. I may be wrong. If you only have one thread, then you don't have to pass in the CPU. Why? Why not? The CPU is basically the state of the running program. Oh, I thought it's called every instruction. No, that would be terrible. If it was every instruction calling a function to generate the map, then yeah, that would be terrible. But yeah, I mean, I don't know. Do I want to create an See, I want to create an exception here, but it just sounds so long to actually do things here. So class my exception. What do I even call it? I don't even know. I don't know. Valid or opcode not supported. And that's going to be a public from std exception. Let's do a private here just to keep the message. Do I even want that? No. Yeah, why not? std string opcode. But we can string it later on. Which means we can do a opcode, or in fact, let's just copy this because I don't want to get any errors. Opcode not supported, and then we're going to take in a string, which is going to be the opcode there. In this case, we're just going to do opcode is going to be std move, I guess. Yeah, std move opcode. Right, something like that. And there's nothing here, but then we do have to do a const car star what, which is going to be an override, and then we simply return going to be very lazy here. I'm sorry for underestimating you. No, dude, it's fine. You're not underestimating anyone. It's a good point. It's a good point though. In fact, I think that the first time I made this program, this emulator, I actually did do exactly just that. I called it every time, which is obviously not ideal, right? Now, do I put the override or const throw in here? I don't know. Yeah, let's just do that. Anyway, so we have string const, and then we have the error message, which is going to be something like I don't know. What do they say? Opcode not supported, and then we can do the opcode down here dot c string, just plus opcode, I guess, and then we return the error message dot c string. Oh, sorry, I've been working with Python and Rust for too long. This is not c string. This is dot data. Or in fact, this is C string. Okay, that should be okay now. So going down here where we had the throw somewhere, we do opcode. Not. What was it, supported or something? Is that correct? Opcode not supported. That was correct. And in here, we're gonna have to pass in that stud.toString. Yeah, stud.toString. Now I want to turn this into a hex value. So I am supposed to be working on parallelizing one of my algorithms, but I've been a bit busy with all of this stuff, so I've been putting it off. Yeah, dude, you are definitely procrastinating there. So that's one of the things I do sometimes, and it's annoying. It's like when you know something is difficult, but then you don't do it, so it just makes things worse. So just try and do it, dude. I managed to get a part-time job at a bakery until I can get an internship at a company. That's very nice, dude. That's very good. Yeah, part-time jobs, especially when you're at university, very important. You can get some extra money, and like it or not, even if it's not in the industry, it still gives you some experience, on how you can talk to people and how you can treat customers and stuff. So it's always a good experience to have that. Anyway, I held a few jobs before I got my first kind of programming job, which were kind of before university and during university. But yeah, it definitely does help out. Anyway, so if you guys are still watching this and haven't liked the video, yeah, please do. I am here for you guys, and yeah, please help me out. So toString, and see, the thing is, I want to turn this into a hex string. So basically a char to hex string C++. That's what I want to do. I know there is some stuff you can do with cout and stuff, so you can pass in std hex, for example, like this. But I want to put it straight into a string, which would mean that I have to kind of put the include the string the O string stream header, or whatever that's called, S stream or something, because you can treat a string like cout, basically a buffer. I don't know what is it called again. What's cout called? It's a stream. The Q is literally in the name. But yeah, I don't want to do that. So question is, do I have FMT here? I'm not entirely sure whether I've got FMT. Because FMT format might be a little bit better for us. And the truth is, I don't know if I've actually included it. No, I haven't. So let's get that, because it's going to be a lot easier for logging, to be honest. Colon.io. And let's just find whatever the latest version of FMT is. So there you go. So 11.2. This library, dude, it keeps kind of going up really fast in versions. So we've sorted it. We're going to have to do a colon install here, just to get the library itself, and then we are doing colon debug, colon release. That's going to be for the release. Okay, so that should sort it out for us. But it does also mean that in my emulator itself, I'm going to have to find the package FMT. I'm going to have to say that it's required, otherwise we're not going to be able to access it. And in here, I'm just going to put FMT, like that. We should have found it. There you go, FMT was found. And, if we're lucky, this header should be found as well. So, okay. But that basically gives us the option to use FMT now. So FMT has a much nicer string thing. So FMT hex strings, right? That's what I want to do. So the formatter, yeah, X seems to be the one, or maybe not. FMT format, there you go. Do I have hex mentioned anywhere? There you go. So hexadecimal output is used up this option, adds prefix. respectively 0b or 0 by or 0x. Okay, so how do I actually use this? Hexadecimal floating point. Okay, so it seems that we do this, right? Something like that. So 0x, right? Let's see that. So where were we again? Throw, whatever I was doing the throw, which was here. I want to be able to do fmt.format. And what did we have? We have, wait, I have that in here somewhere. This is what I wanted to do. Okay, so what actually goes in here? This is my instruction or the opcode that's coming in. Ooh, right. This is interesting because I don't actually have. Yeah, I don't have access to the actual opcode here. You see, because I'm filling all of the default elements with a function, but I don't have the index of them here, which is interesting. This looks a lot like functional programming. Yeah, it is. It is. I agree with that. So the question is, does forward fill actually tells me what the size is? No, it doesn't. And do these actually get executed in order though? Let's see, because if this gets executed in order, I can just do a counter, and that's not a problem. So the requirements, return value, policy, the execution policy. See execution policy for details. So yeah, execution policy is one of those things that was kind of recently added to C++. So you can see since C++ 17 and onwards, which kind of say, like, which order do you want your algorithms to run? So for example, sequence policy will just run everything in sequence, right? So parallel policy may run all of them in parallel and so on and so forth. So parallel unsequence policy kind of does the same, but I guess, yeah, I don't know what the difference is. But I wonder if by default we run everything in sequenced. So the execution policy, is there a default in any way? Oh, no, we don't. Wait, should it not say in here? So execution policy. Well, it doesn't say what the default policy is. I guess we're not using the right overload anyway, right? So this only applies to overload 2, where we actually have an execution policy. So we don't care about that. Which I'm just wondering, does it actually run in order? And if it does, fine. So we can, at the end of the day, we can just do a std size t or something, which will be the opcode. Oh, went too far. Opcode counter, which starts at 0. And then every time we do this, we also... wait a second. I was going to say we kind of count it up. But it just copies the value. Never mind, it doesn't execute anything. What would be the difference between parallel and unsequenced? Or can one run on multiple threads and the other one just one? Yeah, so parallel and sequence will run on multiple threads as far as I know. So this doesn't just apply to this function fill n. So if you're doing something like std transform, for example, that also has execution policies. If you use one of the C++20x calling methods, then you will also get this stuff by default. Hello, Chuchumba. How is it going, man? Good to see you here again. I think it's I've seen you here a few times, dude. I hope you've been doing well. But yeah. So instead of fill n, we can't use fill n, right? So what we gotta do is we just gotta do a for loop, unfortunately. So we are gonna do a std size t I equals 0. I is less than, I guess, 255, which is the size of the supported instructions dot size. And we're gonna do a plus plus I, and then in here we're gonna do something like, you know, supported instruction. I is going to be whatever this is. So we are going to need this. We're not going to need this. Or we are going to need this. Actually, we're going to get just this bit here. Oh, why did I change the method? We're going to need that. Oh my god, what is going on? So view mode, and then we're going to copy all the way. Just copy all of that. Okay. We're going to need something like that, basically. That's what I was saying. And yeah, we're just going to take it by copy, whatever we want, and that will be the opcode counter. Oh, in fact, not even that. So this will be just I, right? Don't need the either. Yeah, I mean, this is the easiest way to do what I wanted to do, unfortunately. Then how would the speed be different for sequenced and unsequenced? Wouldn't it be the same? Yeah, that's what I mean. I'm not entirely sure what the difference is. To me, it sounds like parallel unsequenced policy is the one that you actually think of, you know, running in however many threads in, you know, at the same time. And parallel policy kind of implies that it has to wait, but I don't know. So let's take a look, shall we? So parallel policy. Do we have anything here? No, we don't. We don't have anything here. So do we have just parallel? Yeah, we do. So the execution policy type used as a unique type to disambiguate parallel algorithm overloading and require that a parallel algorithm execution may not be parallelized. The invocations of element access functions in parallel algorithms invoked with this policy are indeterminately sequenced in the calling thread. Okay, so you can't determine things when it's running in parallel. But we have parallel sequence, parallel policy here, which is interesting. 2. This one here, parallel policy. The execution policy type used as a unique type to disambiguate parallel algorithm overloading and indicate that a parallel algorithm execution may be parallelized. The invocations of element access functions in parallel algorithms invoked with this policy, usually specified as SED execution par, are permitted to execute in either the invoking thread or in a thread implicitly created by the library to support parallel algorithm execution. So this says that, you know, whenever you use the second one here, then the execution of your, you know, of your lambdas or whatever, they may run on the same thread or in a thread created by the library. That's fine. Any such invocations executing in the same thread are indeterminately sequenced with respect to each other. So you cannot know which order things are running in with parallel policy. This is very, very, this is very, very like interesting. If the threads of execution created by thread or JThread provide concurrent forward progress guarantees, then the threads of execution created by the library provide parallel forward progress guarantees. I don't know what this means. I guess, you know, if you have a forward guarantee, so you won't go, if you only run from like the first to the end or the begin to end kind of thing, and if you have that guarantee in the threads, then the execution order is also guaranteed. This is what I understand here. In practice, I don't know what that means. To be honest, I've never done anything like this in C++. Otherwise, the provided forward progress guarantees implementation defined. No, parallel forward progress guarantees that if a thread of execution makes a step, it will eventually make another step, enabling threads to enter critical sections and take locks, because the thread that has the lock will eventually scheduled again and be able to release it. Cool. The threads are started in order with the second one. I think, yeah, it's implementation defined from the looks of it. So if the threads that you created or are created by the library have what they call here the forward guarantee, so if it takes a step every time forward, then that execution order will also be respected, I think. I don't know. So third one, unsequenced. What's the difference? The execution policy type used as a unique type to the, yeah, we know that. indicate that a parallel algorithm's execution may be parallelized, vectorized, or migrated across threads. Ah, okay, so there's no migration between threads here. Maybe parallelized vector, such as by parents stealing scheduler. The invocations of element access functions in parallel algorithms invoked with this policy are permitted to execute it in any unordered fashion in unspecified threads and unsequenced with respect to another within each thread. So this one kind of sounds more like async, where you have a workload and you have kind of worker threads, and you may start in one thread, but then you may also start like another workload, which is like 3 elements down in another thread, and they may switch. Yeah, this is we're not going to understand this in this stream, to be honest. This is something that you actually have to kind of understand very well. But yeah, unfortunately, I've never actually played with parallel execution stuff in C++, and I can't really say too much apart from what the docs say. And as we've established before, the docs are not a friendly place for you to learn how C++ actually works, because it's not intended for you, basically. It's certainly interesting. It is interesting indeed, yeah. To me, it sounds like the most beneficial one to use if you're trying to go for a true kind of asynchronous execution would be parallel unsequenced policy here. Well, I don't know. This is something I have to test. You have to study by the arcane arcs of the great parallel. Yeah, indeed. Anyway, going back here. So we've started all of that, which is fine. So we take this by copy. Fine, yeah. And yeah, I mean, now we should have solved the problem where we may have had, a opcode somewhere that was not supported. So where was it again? In execute next. Like this thing here, right? So yeah, this will essentially return something bad, in fact. What we can do is, like, every time we do this, so we can do a try catch here, right? So we do a try to run this thing, and we catch whatever was opcode not supported. If we caught that, then we simply say std.cout or something. Do we have cout in here somewhere? I was streaming, yeah, we do. We end the line there, and then we also say, return is stood, no lot. Now we have some sort of error handling. I'm not a massive fan of throwing things, to be honest, and catching them up the stack, but it's fine for this case. And what should have actually been here was this. So it should have actually returned this, and this should really be out here, because this will not throw anything. So either we return that or we can't. Okay, cool. Now let's compile and see what's gonna give us errors, because I'm sure that we'll get a few errors now. So let's go for them. Fatal error, FMT format not found. Right, so is it .hpp? Did I mess it up? I think it might have been HPP. No, it's not. What is the header actually called? Format header. libfmt. FMT core, is that the one? FMT format. I just want the format. Yeah, it is FMT format, I'm pretty sure. That's interesting. So it probably means that we're not linking it properly. So let's see where it's actually getting the error. So failed when compiling what? So scanning for dependencies. We're building the emulator app. So maybe we've included, yeah, we've included it in the emulator app, but not actually where it should have been, which was in the wrong place. It should have been here. That would have been a little bit better, wouldn't it? There you go. So we've got that there, and we do a target link libraries profiler. Else, okay, so we can also do a target link libraries here. We've got the emulator, and we have public because it's a public header. Oh no, it's just private. But do we need? Do headers cascade in modules? That's what we're about to find out. I have no idea. Because usually, right, in C++, when you have something like this where, you are including a header within a header, the consumers of your package, the people including your header, will also have to have access to the headers you're including. So you have to make them publicly available through some sort of like dependency management, right? But this is not that. This is not a header. This is a module. So I do wonder, like, will this stuff be cascaded? And let's build it and see. Oh yeah, we've established that this is just H. Okay, yeah, that's better. So yeah, we actually went past that problem. So warning, address of stack member associated with error message returned. Oh yes, that is true. Yeah, so the error message we can just kind of that is true. See, this is how Clang is so good. It's telling me that I'm returning a pointer to a stack variable here, which kind of goes out of scope and dies, right? So this is actually invalid memory access. And yeah, it's because of this code here. So what we can do is I can simply save that stack variable or that stack message, that message into a member, which will basically mean that the lifetime of my error message will live as long as this lives as well. But yeah. And then we can just do that here. So opcode supported. Plus opcode. And then we just do message. Now the errors should disappear now. That's better. So error unknown type instruction. Yes, that is correct. Come on, guys. There's a bunch of typos here. No one's helping me out on those. Right. Error use of undeclared supported instruction. Supported instructions. Yes, that's correct. Let's see that now. Now this is interesting. So what do we have here? Unknown type. Yes, I did mean exactly that. What I thought that this is already... Okay, so opcode not supported. Yeah, we can do emulator as well. I don't questions. I don't know enough about the compiler to help. No worries, dude. At least you're getting to learn here. We're getting through the errors one by one. The reason why we're getting so many errors now is not because I'm shit. Well, it is. I'm kind of shit in C++, even though I've been doing it for a long time. But it's because IntelliSense isn't working, so we're kind of like relying on the compiler output to actually help us figure out those errors, right? So yeah. So unfortunately, because we don't have IntelliSense, we're just gonna have to do this way. Okay, so he did build. Now the problem is, have I broken anything? There's only one way to find out. Truth is no, it should be fine now. So things should still run. And this still runs just fine, right? Now the problem is, how long did it actually take? So before it was something like 0.6 seconds or something. You've never seen a compiler error, you're not a real programmer. Yeah, that's true. So what is it taking now? So emulator is... You see this? See this? Execute next itself is taking no time. And yeah. So to do this whole drawing now is a lot quicker than it was before. We went from something like 0.6 seconds. I don't know what it was. It was something like that at the start of the stream to something that's a lot better, right? So just to make sure that this works, if we just run this function here, this line, you can see how fast it actually runs. Like 200 times less. Yes, exactly 200 times less or something. Let's run that. Yep. See? And that was beautiful. Now, this is actually, if you think about it, this is actually in debug. So let's see what we actually get with release, shall we? So like one iteration to draw one screen here, in theory, according to my profiler, is going to take, in debug mode, that is. So yeah, this is absolute, no, never mind. Yeah, 0.5 seconds. Which is better than 0.6 seconds, isn't it? So not 200, not quite 200 times. But if we divide a second by this, how many times do we get? So in debug mode, we can, at this speed right now, which is not the maximum speed that I can go for, I can draw this screen 20 times a second in debug mode, which is pretty good. And right. But that is the thing though. This still has some sort of like speed cap on this. So if we look at, for example, execute, you'll be able to see that I have essentially got a wait, what is my easy 65k? I've got like a what do you call it? A speed cap somewhere because I want to mimic the real time of the actual hardware, right? So I do wonder what happens if I just limit that entirely. And that will be somewhere in my emulator itself. On my execute next, I believe. There is a timer in here somewhere, right? Or maybe not. No, there isn't. So why the hell am I using that? Because I thought I had that. I thought I built in the timer for this. Because every time you kind of execute an instruction, you want it to take the actual amount of time that the real hardware took, right? Because otherwise you have like Super Nintendo emulators that are extremely really fast and you can't play a game. So yeah. Yo boys, how you guys doing? You're great. Hello, Most Light. Yeah, dude. We were just waiting for you. It was right before you clicked off. So how are you doing, Most Light? It's good to see you, man. Yeah, so I do have a CPU somewhere. So struct CPU, right? So where do I use? Yeah, do I not have speed anywhere? No, I think that's a different branch actually. I thought I had the speed. Good. Where the main function is. Oh, where the main function is. No. This is not it. This is not what I'm talking about. It's yeah, I basically built in some sort of like code above there where the main function is. Oh, this is for drawing, yeah, dude. This is for drawing. This is not what I mean. I'm talking about like actually executing the instructions on the real time that the hardware takes. I have a branch somewhere. I suspect I haven't actually merged this to main, where I put a timer on each instruction and make sure that it takes the exact amount of time that we expect it to take, basically, right? Thanks, man. I'm feeling great. I don't think you will remember, but I told you I got rejected a job. Now I got a better offer. Oh yeah, you did. I remember you rejected a job because they wanted to pay you peanuts or something, right, dude? So they wanted a lot of work for for low pay. So I'm glad that you got something better, dude. And do you want to share it with us what it is? Let's just see what you got. I always get a little bit happy when people who watch me actually get a job. There's a few people on Discord who always like message me when there's one viewer recently that has messaged me and I got extremely happy because this guy was looking for a job for literally I think it was something like 6 months and he kind of reached out at first because he was working with me on the Urchin project But unfortunately, I'm not part of any hiring process, or I don't really know many people in the hiring position, so I couldn't help him out. But this guy recently got a job as in a bank in RBS, and he was very happy, and I was very happy for the guy as well, because he's a long time viewer, has been kind of learning with us, and yeah. Thanks, man. I'm feeling great. I don't think you remember. Yeah, okay. I've read that one. Actually, it's like developing a game, but I will only do the UI with Python API. That sounds really cool, dude. So a game UI just in Python. Let me know what frameworks you're using, because that sounds very interesting. But anyway, what I wanted to do is like we can, in debug mode, we can roughly draw on the screen like 20 times a second, right? Which is not too bad. Now, what if we did release? So if we select configure preset and we did clang release and build this. So there is something wrong here. So what library FMTD not found? Is that because of something in the CMake presets? So I think I probably messed up my CMake preset somewhere. Oh no, that was right. Oh, I just hadn't run it. Okay. Oh yeah, never mind. It just hadn't built format for release. That's fine. I don't really know Boost, ASIO for networking, etc. They use like PyTurtle, etc. for Windows. That's very good. I've never used PyTurtle to be honest, but I guess it's some sort of like UI library for it. What I have used, what I have used before is Pygame. Have you used Pygame before? It's like the first sort of like gaming library that I ever used in programming, and it was really cool. So FMTD is still not found. Like why? So what is my Conan toolchain file coming in as? Well, Conan toolchain. Let's reconfigure this. Maybe I just have to do a reconfigure. So library FMTD not found in package. If FMTD is a library, a system library, declare with CPP. No, it's not. Yeah. Conan release. That's what we should be. Oh, okay. Do I mess up something here? Unix route release. Conan release. Yeah. I mean, this should in theory work then. So what is the issue? So release. If I just do that and quit straight away, what is Conan actually building? So build type is still debug here for some reason. Profile build, profile host. Yeah, I'm not entirely sure. Like, what is actually going on? So CMake is trying to find the FMT library for debug mode, but I've got one for release. Which is definitely interesting. I don't actually know what it is. Yeah, so Pygame, let me just go through real quick. So Pygame is this very old kind of game SDL2-ish library for Python. And it was just easy to work with it, to be honest. Like I created a few different like little games, to be honest. And it's something you can work with if you like just getting into programming when you're 12 or 13. And it's very easy to set up. You don't have to mess up with system libraries like OpenGL. But yeah, I mean, if you're trying to get like a teenager into programming and they like doing games, show them this library because it's really, really cool. In fact, do these things run online? Because it will be interesting if it does. Sorry about that. There are some like very involved games with it, like this one, for example. So this whole thing is made in Python. It's amazing, isn't it? Yeah. Anyway, it's a good place to start. Like if you're trying to get into game development and you don't know programming, Pygame is probably going to help you out until you can move on to something more advanced, into a proper game engine. Now, what would be interesting is that if they could make Pygame run on the browser, I don't see why they've not tried to do that, yeah. Because it sounds like it should be. I mean, I know there are projects that make Python run in the browser now. I'm not sure how efficient that is, but in theory, you should be able to run Pygame with, an SDL2 kind of backend because you can compile that with WebAssembly now in the browser. So yeah, I don't know. That'll be a really good project actually. Maybe we can do that in the stream one day. Anyway, so let's see what we are working with here. So this is what we are working with. So it is definitely the case that it's trying to link against a debug FMT library, even though Mike Conan says, build it all for kind of release. So yeah. Other question is why the FMT recipe? Okay, this is not going to help me. Is that the same error though? Yeah. After doing research on this bug, I found the cause of this bug seems to be the following conf argument. So when you're building in Ninja, somehow, any optimization tips for C++? Yeah, we've just done one. we turned the map into an array, and it optimized things quite well. Problem is, I can't see how much better it is on release now because I'm not able to build on release anymore. But yeah. This is not a Python, sorry, this is not a Kotlin recipe issue either. Yeah, let me just see what's on my my default thing, by the way. So we have .Conan, right? Profiles or something? Default, yeah. So build type, let's just put this on release. Right. Now let's just build it again. And what do we actually get here? So yeah, for the profile build, we actually get release now. That's cool. FMT was already installed. Now if we kind of reconfigure, delete cache and reconfigure, does it find it now? No, it still doesn't find it. Like, I don't understand why. Because I do have the build type as release in here, right? Yeah, there you go. These CMake build type. Is CMake build type the right one? That's the question. It is, right? So CMake build type, yeah. So even with CMake build type, is still somehow looking for the FMTD library, which is the debug library. And I don't understand why. I don't want to be like stuck on this for too long, to be honest. Like if we can't fix it in 5 minutes, I'm just gonna remove the FMT library. But yeah, I mean, which select configure preset, and we are using, what is it? Unix Ninja Clang release. Build. Yeah, that's a weird one. So Kotlin release macros, which come from the toolchain. And what do we have here? Hello, Slim. How's it going, dude? Good to see you. Good to see you. How are you? Yeah, I'm good, dude. I'm good. I was in London last week. I don't think you caught that, did you? I was hoping that you'd say that you were around, but I was extremely busy, so I couldn't really meet anyone. FMT debug. Yeah, see, so it's picking up, somehow it's picking up FMT debug data, does he make? Even though we're in release here. So I wonder, is it because it's not actually redoing the files there? So if I go in Conan, and if I go in release here, and if I just remove everything from here, okay? And if I do again a Conan install release, I think it's gonna work because I think it was just not regenerating everything. Reconfigure. There you go. That was exactly the issue. Conan wasn't regenerating the configuration files here because he saw them already and he was like, yeah, I mean, I'm not gonna regenerate it. Oh my god, next time. Yeah, next time for sure. I might be there next month. I don't know. I will let you know, dude. So I think I still have you on Discord. You have an anime picture, right? If I'm not mistaken. So yeah, if I come down to London, I'll let you know. And we can go to Camden Market or something, get some food. Do a IRL meeting. Anyway, so finally we're able to build this in release again. And if we're able to build this in release, we will be able to see how fast it actually is for the whole function. Let's run it now. It was very quick. And if we look at the stuff here, so we have, where is it? Emulator execute. 0.05. So this still looks the same, doesn't it? And it does look the same because I think I haven't actually changed my my debug. There you go. So if I do release here and run it again, we should be able to actually see what's going on. There you go. So it did seem faster. This was actually the release binary in this case. And yeah, dude, look. Emulator execute takes 0.004 seconds. And how many times can we draw the screen if it takes 0.004 seconds? Probably over 400 times. No, 250 times, right? Which is fine. Which is exactly how long you expect this to actually kind of take, right? Because if you think about it, you're doing 0.004 times something like 30. Oh, just 30. So that you'd be drawing the screen 30 times, which, essentially the number of cycles and essentially time that you'd lose would be 0.12. So you still, like, out of every second's worth of cycles in your machine, you still got like 88% of the processing time to actually do everything else in the game, like, recalculating positions, doing collision detection, and and yeah, it makes me kind of feel a little bit better now, to be honest. How would you print the time taken using the chrono or a library? So interesting question. Thank you for asking that because I was hoping someone would ask that. So we have a video on the channel. Let me see if I can find it. So art coding with Matt. Whatever, dude. Just accept it. Right. So if you go on my playlists and if you go onto the, where is it? Emulator for 6502. There is a video here where I explain how I do the cycle timing, right? So the cycle timing, not cycle timing, sorry.
I can't.
That was too loud. Yeah, I think cycle timing is one of them. But it should also be profiling somewhere. Yeah, I thought I had a video on profiling, because for sure I had a video on profiling. Maybe I just forgot to add it to the list somewhere. Profiling, profile, benchmarking or something. Yeah, this is way back, right? This is way, way back. Anyway, point is, most like, I thought I had a video, but I don't, dude. I'm sorry. I am sorry. There you go. Graphics with Raylib. It was definitely after that. How maps affect performance in the 1 billion challenge. Refactoring the C++ emulator. Instruction timing. maybe it's this video. I don't know. I honestly thought that you would be here somewhere. Yeah, but I made my own profiler. That's the bottom line, right? So we've got our own profiler here, and it's not very difficult to figure out how it works. So if you look here, I've got this enable profiler function, and this essentially boils down to, you know, a kind of a RAII object that will start a timer whenever the object is created and end the timer when the object is removed, right? So that's what we do here. And dude, this is 3 months ago. Freaking hell. Vinay Sharma. I still remember that guy. He used to come around all the time. Yeah, I am wondering if this is the one. I'm not sure. And also my bandwidth just goes crazy when I'm streaming. I can't even load a video. Even though you'd think that you'd be able to, right? You'd be able to do that. Yeah, so this is not the video, unfortunately. Yeah, dude, you're just gonna have to kind of like look at the source code. So if you look at the source code, a good place to look at is the emulator.cpp. There is this build profiler macro here. So if you just follow it and see how things work, this is essentially how I build my own. Don't waste your time to show me, man. I'll find out. Yeah, no worries, dude. So, but yeah. It looks like we've done a lot today. We've improved this by like 20 times. But in reality, all we've done is like moved a map to an array, right? So not that interesting. Benchmark stuff. So benchmark stuff actually is the branch that has that. And I'm gonna add everything. So CMake presets.json. Actually, let's just do this real quick. And everything will be inside of the profiler. Right, it should all be pushed now for sure. So Java's here, Java. Hey, Stopu. I don't, dude. I never know how to pronounce the name. Can you please send me one of those links to someone pronouncing your name, because that'll be useful. You know how they had in the Olympics? So how in the Olympics every like commentator would have like a pronunciation audio for every name. Send me one of those, dude. I don't want to get it wrong. I've just learned that you could do multiple select with git add. Aye, nice. Yeah, thanks, man. No worries, dude. I have an interesting topic. One of my most viewed like shorts on YouTube is exactly that. I'm just going through it like in a stream saying like, this is how you guys git add very quickly and do selection. And then it just blew people's mind. Like no one knew about it. And it's an interesting topic indeed. But yeah, anytime you guys see my shorts, make sure to like it. Make sure to interact with it, especially comment on them, dude. Just the commenting makes engagement go up, which makes views go really, really up. And the more views I have, the more streams that you guys get. Just so you know, because the more money I get. But yeah, like saying it like I earn thousands and thousands of pounds on YouTube. I don't, by the way. I earn something like a tenner every month, which is not enough to survive. But anyway, so that should really be in here now. So if you look at the emulator, there is a branch here for you, benchmark stuff. Look at this branch here. This is the one you kind of want to look at if you want to understand how the profiling stuff works. That is it. And right, so let's take a look at what else we can improve, because we still got some time on the stream. I don't want to leave now. So we've essentially moved this thing here, a map to an array of instructions, right? Which is good. So what do we do now? What do we do now? I am wondering, should the no-op operation actually return no-op, or just like 0, which indicates how many bytes we read? Put software into Google Translation, Polish to English. That is true, yeah. Let's do exactly just that. Translate. So we have, actually, what did it say? I'm not going to say that. That is very rude. But is that what it means? Raccoon.
Sopu.
Sopu. Hello, Sopu. There you go, dude. I can finally pronounce the name. Yeah, taking a look at what we can do here. So we solved one of the issues. There was another couple of issues that I had on my emulator as well. So if we look at the issues here, we have improvement CPM. What is this? How about moving your CMake build script towards CPM? This would make finding much more easier. I have no idea what CPM is. What is CPM? Does anyone know? What is CPM? What's this guy talking about? CPM, C++? It's a package manager. Ooh, it's a package manager. I cracked up at the Hungarian translation. Yeah, me too. Me too. I didn't want to say it in case I get demonetized on this video. So CPM, setup free CMake dependency management. CMake is a cross-platform CMake script that adds dependency management capabilities to CMake. It's built as a thin wrapper around CMake's fetch content module that adds version controls, caching, a simple API, and more. That is very promising. That is very promising, and it's new. Any downloadable project or resource can be added as a version control dependency through CPM. It's not necessary to modify or package anything. Projects using modern CMake are automatically configured, and their targets can be used immediately. For everything else, the targets can be created manually after the dependency has been downloaded. That is really cool. I like that. So CPM package add. Okay, usability seems fairly simple as well. So how do we actually like see which recipes they have here? Because there will be like a supported number of libraries, right? In Polish, stopu means raccoon, and I took first word and added to. Ah, okay. His Discord ID Sopu. I thought it was you. Yeah, it is him. It is him. CPM is interesting. Package manager you can use like directly Git on anything. Yeah, I never saw it before. This is the first time I'm looking at this, so it's definitely something I'm going to try in the future. Maybe this could be our next stream, right? That's most likely to get a lot of views, right? Because people will be interested in this. CPM looks interesting. Yeah, it does. It does. I'm gonna say it myself. I am liking what I'm seeing here. I am liking what I'm seeing. I've never seen it. Pretty sure it's better than VC package. Is it better than VC package? I don't think so, dude. Like this is done. It seems like 2 years ago that was the first release. It's not even got like a 1.0 release yet, so they're not saying it's stable. But let's see. It has 2 years is a long time to be in development. It's got some Ruby in it as well. What? It has some Ruby on Ruby. That is interesting. Contributors. That's what I was looking for. So first commit. Let's see when it was. Let's see how long this is in development for. Hang on tight. Dude, why is this taking so long? What has Microsoft done to GitHub? Why is getting a simple graph of the commit just taking this long? They definitely don't have a vector database, do they? Yeah, there was Ruby in it. If you look at the stuff, rewriting Rust. Yeah, rewriting Rust. See, I'm gonna wait here for as long as it takes. The graph is still being pulled. Calculating graph. Calculating graph. Yeah, we're not gonna get that. Anyway, it seems like it's just over 2 years that this has been in development for. I mean, the license is probably one of the first things they've added, right? And well, VC package, C Conan, those things have been in development for way longer than that, right? So since 2016, 2017. So I would say, it will take a little bit more than this to be better than those package managers. But I like the fact that this is simply a CMake wrapper with Ruby. Apparently, there's a bit of Ruby in there. But yeah, what about Hunter? I've never heard of Hunter either. Yeah, I'm gonna save this. Like this is looking interesting. I'm gonna definitely star it. Oh, on my main account here on the side, I'm gonna star that, and I have started. So yeah, I mean, this guy might have a point. I might have to take a look at this at some point. Investigate why it would take so long to execute the program. Yeah, so okay, so we've done this. We've kind of done this one. Remove the instruction map. We've done this as well. No switch case was necessary. Simple way to benchmark performance of instructions. We've done that as well with this thing. Oh, we've killed a bunch of these in one go, actually. Could this replace Conan? Could this replace Conan? Yes. Do I think it's going to replace Conan anytime soon? No. For the same reason as I just explained like a minute ago. It would take a lot of work to be more feature complete and stable than Conan and VC Package are. So yeah. There's no Ruby code, only tests. Oh, okay. Only tests created in Ruby. That's interesting. But I do like the fact that it's just solely a CMake wrapper. And that has I have a lot of respect for that. They managed to do something that, eventually VC Package and Conan, they're written in languages different to CMake because I guess it's just easier to do programming in it, right? But the guy who made that was just straight up like, I'm going to do everything in CMake. I don't even care. Which makes your projects a bit more portable, right? Because every platform that supports CMake, you'll be able to sort of like bring your dependencies onto. With Conan, obviously you have to have Python installed, which isn't ideal. And well, VC Package is written in C++, so it's still just as portable, I guess. But yeah. Are you TJXX from Discord? Yep. What gives it away? To me, is the picture. It's kind of similar to your picture on Discord, isn't it? Anyway, yeah, maybe we can just chat for a bit. I don't think I'm gonna get anything like meaningful done apart from just looking at the code. Maybe we can just do that anyway. So, right, one of the things I wanted to check as well is whether or not we have broken the tests. Have we broken the tests? No, all of them still work just fine. This whole thing is being like covered by unit tests. For those wondering, we have Google tests everywhere. So I have all of the transfer stuff here. I have all of the storage functions in here. All the LD functions in here. All the comparisons, branch, incrementation, zero page, and decrementation, right? So I do wonder, like, how many more? Well, I have about a lot more to go through here, to be honest. This picture is, I don't know anymore. I grabbed it from somewhere when I made this account in 2014. That's better than me, dude. I mean, I still have my, Linkin Park picture from when I was like 8 years old. The first time I created my like Google account. So I still use that, dude. Yeah, it's time for a new avatar. Yeah. Papu, I like your avatar, dude. Yeah, so I'm kind of wondering, like, what can I do here in this emulator? Obviously, the good thing to do would be to support more functions, right? So let's maybe take a look at one of them and see what we can actually support here. So, I don't know. So CPY, compare with Y. Do I have compare functions? Compare immediate register 0. C0, yeah, I have CPY there. CPX, do I have that? So C1. I don't have this one yet here, so I guess I can add this one. So compare with X, which is C5, right? 0 page. Okay, so we compare 0 page. And if I'm not mistaken, I love Linkin Park. Yeah, so do I, dude. That's why I still have my avatar as Linkin Park in various places. It's funny because when I apply for jobs, I apply for like big boy jobs. I'm nearly 20, 29 or something, applying for like a senior a senior job somewhere like Microsoft or whatever, and then they just see this Microsoft profile picture and think, what the hell is this guy doing? And yeah, I refuse to remove it. I just refuse to remove it. It's just so old that I'm never gonna remove it. I never really listened to it. I think I was off by a couple of years. You were all off by a couple of years. You were all really young, I think, including Sopu. Sopu is really young, so watch your mouth. Don't say any bad words, you know. The stream is kid friendly, shall we say. That was a joke, by the way. But yeah, you guys must be what? In your university years, so some of you will be something like 20, 21, 22. I've been there a long time ago. I'm nearly 30 now. I'm 28. So I'm old enough to be your granddad. Right, 0 page. C5. CPX. Wait, what? I thought C5 was just... Wait, have I not already done that? So C1. C1, there you go. Indirect with X. Okay, so this is addressing mode. I need to like refresh my mind again, because indirect mode X, basically you take whatever value is somewhere in memory in this indirect, you add X to it, and that is the value that you dereference to compare with X. And yeah, so let me do a refresher on this. It's been like so many months. 0 page, wait, access 6502. Addressing modes, that's the one. So addressing modes, immediate mode. These instructions have their data defined as the next byte after the opcode. So ORA will perform a logical, also called bitwise, or I guess, of the value B2 with the accumulator. Okay. Remember that it's in assembly when you use a sign. In assembly, when you use a sign, indicates an immediate value. Yep, we know that. If B2 was written without that, it would indicate an address or offset. Yeah, so this is the immediate mode. So this is not what we want here, right? So we want C1. How have I got all of these in the first place? Before I do anything, so I have compare, which is C0, C5, and E0. C0. Wait, C0? C0, where's C0? What? Oh, there you go. So C0 was this, which is an immediate mode. C5. Oh, okay, I see what I did. So I've implemented a function for all of the immediate mode access and reuse that everywhere, right? So actually, this is the immediate mode compares to registers. What we need to do right now is do the 0 page, right? So let's do the 0 page simple. And every single one of these registers has a compare function. So they will compare whatever value is in the 0 page, given by the bytes, the operation, the operand byte, into whatever is in Y, right? So that's what we're going to do. So do support for compare 0 page without X. 0 page without X, yeah. 0 page simple. Okay. So no, I love Linkin Park. I never really listened to it. No, I'm being a high schooler since 2nd September, dude. Yeah, that's young. That's young, dude. You need to grow up, man. What? How old are you, man? I'm 27. Yeah, slim. You're like myself, dude. A proper adult, I guess. I'm 23. I'm flabbergasted. That's what I'm saying. You know, be careful what you say on the stream because we do have some teenagers. We still have some teenagers on the stream. But it's fine. We're friendly to all ages, right? We're friendly to all ages. I'm finally an old man, yeah. Yeah, so we're going to do something like supported instructions. And this is where we're going to get these things. So we have C4 here. Actually, let's start with compare. So compare just does A, right? So C5 is the one that we want. Oh no, what? We already have C5. What? Is there a bug on this? Compare immediate 0 page. So C5 is already here. Huh. So I already have a 0 page one there. So it should just be as easy. I mean, this has to definitely be moved down. And instead of that, we have C9 in this case. So compare immediate register. That would have to go here for sure. And this would be emulator. Registers Y. Oh, sorry, this should have been A in this case. Now, I don't think there's anything special in this case. Bytes takes 2 bytes. Immediate takes 2 bytes. Yeah, so all of these take the same number of bytes and the same number of cycles, which means that we can reuse the functions for sure in there. All my friends listen to new bands and singers, and I listen to Linkin Park. So at least I'm relatively old. Yeah, don't say that, dude. You're really making me feel really, really old. You know, I still remember when I was like essentially a child, when I was like 6 or 7, even younger than that. And Linkin Park would play on the MTV, and I believe the young ones will not even know what MTV is because they would have never like seen it. But yeah, Linkin Park was on the MTV all the time in Brazil, and I just loved it, man. It was my go-to band for my entire life because I still listen to them. But yeah, whenever I'm coding and I've got Linkin Park on the background, I just feel like a hacker. Just put it that way. Now we need 0 page. So we've got C5 already there. We have E4, which does X. E4 will do X in this case. So 0x E4. Just lowercase that. And that is it. CMP 0 page register. And that should be emulator. Registers X. I'm just going to double check that we do also have 3 cycles everywhere. Right, there's 1 extra cycle. There you go. MTV was sick. Yeah, MTV was sick, man. MTV was sick. I've discovered so many good bands through like MTV and Kerrang and those channels. My System of a Down is another favorite of mine that I still listen to. Basically, not every day, but every week. And then we have Y, which is C4. C4. C4 mentioned. Counter-Strike mentioned. I think Y in this case, and there you go. Now, I definitely need to do some like testing for this. And I definitely need to do some testing for this. And I definitely need to do testing for, was it C9? Yeah. So maybe we can do at least one of these so you guys can see how it's all been tested. So we have compare tests here, right? Now the question is, do we actually have branching tests? We don't seem to have any branching tests, which is interesting. I mean, comparing tests. So, LD indirect tests, emulator tests, branch tests. There you go. So what does that actually do? Do we have A9 in this case here? Yeah, we don't. Yeah, so all of these tests, just so you guys are aware of what this is doing, we have to like basically create some very small programs that will kind of test each of the opcodes individually. So for example, in here we have 4 different programs where we have the test data. Test data in this case is just a pair of an array and a uint16, meaning where I don't actually know what this means. Oh yeah, the expected PC counter in the end, right? Which is fine. Is it? What's the reg PC? I can't remember this now. Test data programs, program expected PC. So I don't even use that. Interesting. But anyway, yeah, so every test will kind of create a very small program, and then we'll execute that program with the emulator execute function. And we probe into the CPU to see like what register values we have, what flags we have set, and so on and so forth. And yeah, this is how we do a test for this, right? So in essence, what we would have to do here as well, we have to create a new file, call it compare tests. And then we basically just add into the CMake. I think we have a create tests function that I've added ages ago, and we do compare tests. That should add a target. And in that target, we have to actually kind of copy and paste some of the stuff here. There is a whole description for all of these tests, and I'm not going to bother doing all of these things. By the way, I've never used TikTok. Never used TikTok. I mean, I have. I'm less old than you in that case. So go to school and try to find someone who has never used TikTok. Yeah, I mean, it's difficult. TikTok is the YouTube of a generation, right? I mean, we all watched YouTube back in the day. We all had Facebook, and now everyone's just shifted to TikTok, and it's just the way it is, right? But oh god, I am wondering whether I should do this off stream because adding tests is not going to be kind of interesting for you guys, but you can kind of see what it's doing. Let's just copy and paste some stuff. Emulating tests, and then we do that. And we're going to leave one of the tests here. I'm going to remove everything. And we'll leave that, right? So yeah, in here, what I would ideally do is create a very small program. And then I have like some dummy values on the CPU registers already to make sure that we have like flags set, and then we can compare certain values to A and stuff, and yeah, make sure that it does what it's supposed to do. And we have to do this for every single one of these functions that I've added just now. And it's very cumbersome work, I'm not going to lie. I mean, covering everything is difficult, but I'm not going to do that on the stream. No, adding tests is interesting. I am trying to use dependency injection for tests, but it's kind of weird. Are you not supposed to be mocking stuff, dude, instead of a dependency injection? Are you doing that in C++ as well? Because if you are, then there's gmock. Gmock kind of helps you quite a lot. I'm just going to chat with you guys for a bit before I call the stream. What's up, Matt? Hello, Robin. Oh, dude, I'm so sorry, but we're just at the end of the stream. We're talking about your program at the start because I showed these guys what the emulator actually does, and it only looks cool because you did it, dude. So that's the guy you guys can thank for having actual visuals on the stream. Yeah, C++, Slim. So yeah, Slim. So if you use gmock to create mocks and stuff for unit tests, that might help you out. So no, Google Mock is the one. So it's part of Google Tests, I think. So, but this is the go-to kind of library that I use, everywhere. Or it has been achieved. Yeah, so it's part of Google Tests now. So it's just you can look at the primer. Oh, one second. Someone knocking on the door. yeah, so you can look at the, going back to this, you can look at the primer here to see how to use it, but it's essentially just yeah, just straightforward mocking. It's not difficult. I know one person who just graduated to a bachelor's and watches TikTok. Some people just relax. Yeah, I mean, it's just a way to kind of tune out. Anyway, I'm going to call the stream here, guys. I think I'm getting tired and I need to kind of wake up early tomorrow. But thank you very much for joining, and I hope you guys can like the stream at the very least. And stay tuned because I'm going to release a new video as well, especially for those who are doing C++. It will be on how you can debug C++ projects in the proper way today. Because the video I did on it was kind of outdated a few years ago, and I've re-recorded it. So yeah, it was a nice stream. Thank you, Robin. You only joined like the last minute of it or so, but yeah, maybe we'll catch each other at some other stream, dude. But anyway, I hope you all have a good week, and in fact, a good weekend, right? Because I'm probably not going to stream until the weekend. And bye bye, guys. See ya.